Hi, David. Get things set up here. It's actually kind of easier when I'm on Zoom at home. I found like, oh, I can have my monitors up and have things situated. How are you doing? Can you hear us?
Glad to see I am here at the right time. I was just texting David Cly. I can never. My Tuesday class, I'm like always like 30 minutes early for, but I thought I did it here too now. Anyway.
You're good. I think though we're missing, hello. I don't think I got any messages that she was gonna be late at all. So, yeah. Well, I have 70+ slides to go over today, so we best get started. Don't blink. We probably won't get through all of them. It'll be a balance between, how much hands-on you guys want to do with the computers and SPSS. And how much you're just, okay, just show me how it's done. I put together the presentation. So that is kind of like a guidebook. Like with my ArcGIS class, usually I record what I'm doing, how to do stuff, but then students told me they really liked it when I took screenshots and had steps on this is how you do clipping, this is how you do whatever you have to do. And so I put together this presentation kind of as a guide. So if you forget how to do it, you can come back and you can see the buttons are all highlighted in orange as far as what steps to do the various assignments, like the questions that might be on your assignment, or when you finally get to your analysis, you're like, how the heck do you do this? You can go back to the presentation and it'll be a guidebook for how to do that. So
Okay,
let me share the screen here.
yeah, that really helped me a ton, being able to rewatch the video. And like just go more slowly at my pace was, and then was able to, do like.
Data view versus variable view and stuff like that.
Yeah.
Yeah.
Explore a ton, it was helpful.
Mm-hmm. Yeah, and with like, the GS class, everything's recorded, so the students can pause it and do it on their computers and come back, and so I'm kind of trying to do it the same way since people like that.
Okay,
All right, so let's
Yeah.
see.
and then during class, I was just trying, like, okay, geez, how do we got 5 minutes to do this.
Uh-huh, yeah, it's hard to keep everyone together, and I mean, we're a small class and it's still challenging, so. But technically, we're gonna start to cover 4 chapters here. So still talk more about descriptive statistics, the survey scales. That just kind of comes from looking at the data and when we're analyzing, say, like ordinal versus nominal, learning about the different types of data and how to plot out frequencies. We're gonna get into exploring relationships, so measures of association. I really need to stress that measures of association aren't like statistical tests where you get p-values. They're statistics, but you're looking at, is the association weak, moderate, strong, things like that. Are these two things kind of correlated? Not causation at all, but correlation. And then if we have time at the end, I'll get into some linear regression, hardcore statistics type of stuff. All right, so we left off before, I'm gonna hide these meeting panels. And if my screen isn't sharing, David, or you have questions, please just shout them out.
Okay.
Okay. All right. Hide this too. So, we, started with SPS and I think we left off at describing the data, and I showed you guys, how to get the display names up and how to do labels. So, where's my mouse? Can you guys see my mouse at all? I can't really see my mouse. But you can see highlighted in there how you can go to edit and display names and change how that's viewed. So I think we went over that. And then the output options, I believe we changed these to names and labels in everyone's, we did this, right? And then that data versus variable view, that was down when you open up the data set, and it is down at the bottom. And the data view will show you either the numbers or they'll show you the text. So say for sex, it'll either show you 1, 2, or it'll show you male or female. In this variable view, you can get at, what do these labels mean? One of the things in preparing for this lecture, I talked about the confusion with this data set and how you have both values and you have labels. This actually can be helpful if you have ordinal data. Because with ordinal data, it might just separate it alphabetically, which really might not be what you want. If you're going from strongly agree to neutral, when you sort it alphabetically, it's gibberish. But if you gave it actual numbers, like from 1, 2, 3, 4, strongly agree is 1, agree is 2, then when it runs the analysis, it'll sort them in the right order, a meaningful order, from most agreed to least agreed. So it is kind of helpful to have some of these stored as numbers. We talked about the importance of missing values. You really need to think about these when you're doing your percentages and calculating up how many people, what percent of people said this, what percent of people said that, because you don't want to include missing values. That's going to skew your results. If people didn't provide any information, then that shouldn't be summed up in the total sample size. Okay? I believe we went over frequencies. Did we get into frequencies? A couple weeks ago?
I remember that we did right at the end.
Right at the end, okay. I think we were talking about frequencies, because I remember, I think David online, you got to this and it wasn't displaying the variable names. And so we had to play around with yours and how to get it to display. And if it's not displaying properly here, you can always right click. Always right click and change the view of your variables if it's giving you something silly. Okay. All right, so frequencies, and to do frequencies, it's just analysis, descriptive statistics, and you go over to frequencies. And as you'd imagine, a frequency just tells you what percent of people responded in the various manners. In this example, 48% of the respondents said that they were Protestant. You'll see the missing values down here. The missing values are not included in your totals. That's proper. That's how it should be. If you didn't identify 99, 98 as missing, then they would be thrown up here. And many students get these questions incorrect on the homework assignment because they don't look at the frequency table and figure out where their missing values are. And so they'll calculate these frequencies with these in it. So really be aware of that. Okay. And then, you can hide variables. That's not really important. If you needed to do many different variables at one time, you don't have to sit there and do each individual frequency. You can add all the variables that you want at one time, and you'll get how many people said attended church, the categories for that. How many people believe in a post afterlife? You'll get the frequency for that. So it'll separate them out for you. So you can do multiple variables at one time. It won't combine them, but you can do many of them separately. Okay. I believe this is where we left off last time, was this issue of trying to collapse categories. And this is a frequent, problem with surveys, interviews, when you start to code stuff. You just get way too many categories. Like, I don't really need to know all these different categories for attending religious services. Less than once a year, several times a year. So when you want to narrow things down to say like 3 or 4 categories in this situation, it's called collapsing the variables. You're collapsing them down. The other reason why you want to do this is you don't really have any statistical power when you have so many categories. You need to have a much bigger sample size to try to differentiate all 8 of these categories versus if we say try to differentiate between 4. So and many times it makes sense to collapse these, but it also goes into survey design. If you design your survey well, you probably won't have to do this collapsing. Okay? I think I'm not gonna have you guys make your own collapsing categories. I built a new database for you guys to download from Blackboard that we'll use when we get into the exercises, but it's relatively easy to do. So in SPSS, you would go up to transform and you would recode into a different variable. It's always a good idea not to mess with your raw data. So don't mess with your original variable, make a new variable in case something goes wrong. Because even when I was doing it, I messed up and something wasn't right and I had to do it again. So transform and then into recode different variables. And in this example, we're gonna take this one called attend, which is attending church. And we're gonna call it a new variable called CHATT. And it's gonna be recoded church attendance. In order to make this happen, you have to hit this change button here. And once you hit this change button, this will change from attend equals a question mark to attend equals chat, so whatever your name is here. So you fill this out, you hit change, then you go to old and new values. And this is where you do your recoding. So first you need to decide how you're going to recode or collapse your variables. In this case, what we did is we wanted a column of about weekly, which is 6 through 8 in this example, nearly every week, more than once a week. So 6 through 8 is gonna be called new variable 1, and its label is gonna be about weekly. And 4 through 5, so 4 is once a month, 2 to 3 times a month, that's gonna be called variable 2, and it's gonna be, you know, monthly, about monthly. And then 1 through 3 is gonna be 3, and we're gonna call it seldom. And then 4 is never. So we took all these 8 and collapsed it into 4 categories. It's also important to remember to transfer your missing over. So again, your missing values need to be coded as missing values in your new column in your database, in your new variable. And so here I can show when I hit change, see how this changes to chat. It went from a 10 question mark to a 10 chat. All right. And then when you're in here, this is kind of what it looks like. You choose your range. So 6 through 8, I'm gonna code to the new value of 1. And you step through that for every single one. So 6 through 8, you would do, then after you do that, you do 4 through 5, and then you do 1 through 3. And then remember your system missing equals system missing. So pretty easy to do actually. And so ultimately, this is what, say, the box over here looks like. It tells you I'm taking the original value 0 going to 4, 6 through 8 to 1, 4 through 5 to 2, and 1, 2, 3 to 3. So, and then you hit continue. And it's done. It's, yeah, that's all. It's pretty easy and straightforward to do.
Is there a way that you can have a window? I'm like trying to do this along with you. Is there a way you can have a window of the old values up while you're in the window of recoding the variables? There probably is, but
I found that actually to be quite challenging. That's why my first comment was figure out your classification ahead of time, because I was like, oh crud, I can't go back and see it. So I had to take a screenshot of what the labels were and have my screenshot up while I did it. So
okay, yeah.
no, it doesn't make it easy on you. So we could go through, We can do it in an example. I want you guys to be able to actually do stuff. So why don't you guys fire up your SPSS? Since David's trying to do it on his end. And let's just open up your database that we used, you know, the other day. Yeah, that's an annoying thing, yeah, David online that I didn't like, cause I couldn't see mine, and I even tried to go up over here, you know, and have it open, and then go up to analyze, but it blocks you, it doesn't let you do that.
Yeah, it's like it has that active window disables the other windows
Yeah,
feature, which is probably a reason.
yeah. So why don't we try to reclassify age into something called age cap? Okay, does everyone have their SPS up?
Just about,
And the reclassification that we wanna do is we want 18 to 20-year-olds labeled as under 21, a value of 1. 21 to 39-year-olds as a 2, and the label will be 21 to 39 years old. 40 to 64-year-olds, 3, an appropriate label, and then 65 and older. The oldest person in our data set is 89. So, how do you get this recode box up? Walk me through it. How about David online, since you have your SPS up? What's the first step?
Okay, so first step is to figure out what variables you want, and screenshot them. And
Yeah.
make sure that they're in the format you want. But you already said that. So first step is transform.
Yep.
And then separate it into little boxes. So like for me, the second little box has a few different recodes, and I would go recode into different variables. Although automatic recode sounds tempting.
Yeah, I don't trust typical software, but you're right, recode into different variables, right? So we get our window to pop up. You guys got that?
I did get that, but I can't get it to show the variable names. I get it to show what it represents. Oh, sorry.
So if you're having that problem, right click on it and change this. On a Mac, I don't know if it's also a right click, I don't, yeah. Cause David had this problem, but he solved it online.
Yeah, Claudia, is it still hurting you? Is it working?
I fixed it.
Fix it, okay.
Okay, cool.
David in the room, are you good?
yeah, I'm there.
Okay, so let's find age. There's age, and then you just click this button, add it. And then we wanted to call it age cap, all caps. And I think the label was recode of age. So after I enter that, what should be the next step? How about Claudia?
It changed.
Hit change, exactly right. So this question mark will then change to age cap. Okay? Are we good? David, it looks like you're still working on it.
Yeah, my mouse pad hasn't been working today, so I have to use the touch screen.
Mouse. I don't think I have a spare mouse.
Actually, I might use spare mouse.
Okay. All right, so then you click old and new values. And I'm gonna put my PowerPoint up here, collapse it here. And that way you can see what I want you to recode. So I want you to work on recoding it based on what I'm telling you to do here, okay? Let me see if I almost, while you guys do that. Okay, let me know when you're done, both David online and Claudia, you're done, okay, Claudia's done, David?
No, I'm still going.
Okay.
Oh.
In case you need one, that one. Okay. So, David in the classroom, you can work on that, I'll look at Claudia's. Okay, one of the things that I do is, just to be safe, I actually do both of these
Oh,
systems
okay.
missing, just to be extra safe.
Okay.
Yeah, there you go. All right.
You know, the stage I'm missing is the new value labels. I actually don't see where to put those in.
Okay,
Um,
so we come over here and, Claudia, can you tell me what it did? It was like range 18 to 20?
But you click the one above it,
Okay, yeah, that's right, range 18
through 20.
through 20, yep.
Oh,
Ah, sorry. I'm holding a mouse and trying to do this at the same time. And then the value up here is 1.
Mhm.
So new value up here. And it was 21 to 39.
Yep.
And the new value is 2. Does that make sense now, David?
yeah, the part I meant was the value labels. So like explaining what the new coding system meant.
That's the next step. Yep, that's the next step. We have to do that somewhere else. So I think, this is what I did next was that. And then I think this was 65 through the greatest, and I think I called this a 4. One thing I told Claudia here in class is with the system missing, I usually do both of them. So system missing, system user missing, I usually add both of those. Make sure my bases are covered as far as system missing goes. Okay? So let me know when you got it here in class. The other way to do this, go ahead, David.
So if the total hypothetical here, let's say I recoded the ages and forgot to include missing values. Can I add a category to the thing that I already recoded, or do I need to go and delete it and then do the recode again?
That would be interesting. I'll try it on my database and let's see what happens.
On the
Okay.
side.
I'll check it on mine and I'll see what happens. So I'm gonna click OK, and I'm gonna click OK to continue.
Yeah.
And so now we go down to the bottom here of our database, and here's our category. Now, here's where we assign the labels. So you have to go to values and then click on this, like 3 dots there. You see there's no values at all here. We gotta manually add them. So we had a value of 1. And that was under 21. We had a value of 2. And that was 21 to 39. 3 was 40 to 64. And then 4 was above 65 and older. So you clicked OK, David, right?
Yeah.
Yep, and now go to the variable view and down to the bottom of the table,
Yeah, HCAT.
HCAT, and then go over to values and click on it, and you'll kind of see this 3 dots come up here.
Yep.
Yep, and now you gotta manually add, this is again, you gotta remember what values did I have? In this case, we had 1, 2, 3, 4. This is where you put your labels. That answer your question, David, online?
No, my question was if I didn't include missing data, as a,
Oh.
in the original recode.
Yeah, but your first one was how to do the labels, so we got that one taken care of.
Oh, yeah, sorry.
Missing
I-
values,
that was
let's see. Let me see if I can filter this at all. Let me see if I can sort and see under 21. Let me see if there are any missing values in here. Probably very rare. Let me go over to the original age and see if I can find the missing values. Okay, so we do have some NAs here. Let's see what it did in that other column. So age, we have NAs down here. Let's see what it did in our new column. It called them 65 and older. All right. So I was hoping it would put them as NAs or just leave them as an 88. It did not. It just coded them as 65 and older, so the other. Let me see if we go to variable view here and define our missing values. It was 98 and 99. I'm just playing around with this and seeing if this works. Okay, let's see if it changed them. No, it did not. So if you do mess up and you forget to do that step, it looks like you've got to redo everything. So if you forget to put in your system missing, yeah, it doesn't look like there's a way to go back.
Okay, thanks.
So that's another reason, very important to not mess with the original data, make a new column. So. Okay, so this is bad data. All right, okay. That's how you recode the variables. So like I said, I have a new database for you online where we make these other ones pull rec. That might be a homework assignment for you to do. I'm not sure. I changed up the homework assignments, but, yeah. And then you can redo your frequency distribution and you'll see that you have a lot fewer categories. Okay. This is just descriptive statistics, frequencies with sex. You guys did that, before. One thing, like with sex, when you get the frequencies and statistics, you know, you can do quartiles, you can do mean, median, mode. Remember, it's coded as 1s and 2s. This program will let you do stupid stuff. It won't tell you you're wrong and you can't really do that analysis. It'll give you the mean of a 1 and 2. But that 1 and 2 means male and female. So it'll allow you to do the analysis of a mean when you're using categorical data. So you gotta really, I mean, the big thing is know your data. What kind of variable am I dealing with? Nominal, ordinal, interval, or racial? Because if we go back and we look at SPSS here, and we find sex. Sex, male and female, but you know, if we change how that's viewed, it's a 1 and a 2. So if I go and I want to analyze descriptive statistics, frequencies, and I put sex in here. And I go to statistics, sure, I can take the median. And I can get a result with the median, but it's not gonna mean anything. It didn't add it to this, let's see, statistics. Yeah, okay, I do have a mean, 1.55. Yeah, It doesn't make sense.
Okay.
So it does let you do dumb stuff. So what would be the more appropriate thing to look at if we wanted to look at descriptive statistics, frequencies, and sex? Of this central tendency, what would be the better central tendency to look at?
Probably the
Yeah, probably the mode. Yep.
Although in defense of the stupid average, it gives you kind of a ratio between the two, right? It's might be better than both.
It could, in this case, yeah, it could give you a ratio of males to females. But yes, it could. That wouldn't be the way that I would go about it, but, it's not totally invalid. It said 1.55, so you're skewed more towards whichever one was called number 2. But the mode here, number 2, that kind of corresponds to the 1.55 we got for the mean. So yes. So you are right, though, the mode would be the more, correct central tendency to do with this data. Okay. All right. So, yep, you guys got it correct. Mode is the one to do. And, it's frequency statistics. So age, I want you guys to tell me what is the median age within our data set. So what is the mean age in our data set? Let's see if you can do that analysis. Let me know when you got it.
You said the median?
Good
Or the mean, let's do the mean. You got it, David, online?
No, but I'm sure I will as soon as I find the button.
So is the median age 48?
The mean is, I don't have the median up, sorry.
Oh, sorry, the mean.
The mean I have is 48.97. Claudius, yes, is that what you got, Elo?
Yeah, I got 48. I put median instead of mean. Sorry, I misheard.
Well, those two are very close together. What does that tell you about your data? If the mean and median are pretty close.
It's uniform.
Yeah, it's not too skewed, not pulled one way, pulled the other way. And I'll show you a picture. David, you look confused.
Okay.
But okay, so yep, you go to that and you go to options and see, you can check all of these, like measures of central tendency. And then, yes. I have a mean of 48.97 is what I got. Okay? And then you're like, well, I want to see a picture of my data. So let's do a histogram. Histograms are always a great way to visualize your data. So to do a histogram, you go to graphs and then down to histogram. I'll do it on my end too. Put age in there. Add that. And then hit OK. And it pops up. Okay. All right. Everyone online good with that?
Yeah,
Yeah, this is pretty cool.
Okay. And
although
I don't,
there's something funny about the histogram based on what we were just talking about. So we were just saying like, oh, isn't it cool that like the mean and the median are so close together? And I immediately pictured like a perfect standard distribution. And then there's this dip right at the mean and median. That's neat.
It's kind of bimodal, yeah, I'm not sure why, in the center, maybe people get too busy with life here and don't fill out the survey. And then I get back to retirement and have time, I don't know. But yeah, it's, you know, it's pretty uniform, there is a little bit of skewing towards the younger end, which kind of balances out this, yeah, a little bit of skewing down here, but it's not horribly, you know, misshaped. So, yeah, and then, you can always like right click on it, you can always like export it as an image, you can edit it if you wanted to add. There's different things you can add to it, like when we get into regression, we can use this edit to add the line, the linear regression line to your graphs and stuff like that. So, I don't know, whenever in doubt, click and try things. Like ArcGIS, just click on stuff, things will happen. So this is a nice histogram for you, to do. I believe I asked you to do one in the assignment for a different variable. Okay. All right. So we have the histogram there. And I have some instructions as far as if you wanted to save your code, how you would go about saving your code, adding information, like if you want a better title for your graphs and stuff like that, how you do it. I'm not gonna go over the fine details of exporting and doing that. I think I'm gonna get into exploring the relationships, so those measures of association, so some actual analysis that you guys might do for your research projects. So we'll talk about crosstabs, mostly crosstabs today, and measures of association and correlation, and then regression. The reason that you do this is, you know, to compare groups. So say you're doing a survey, and I think Claudia, in yours, I mentioned it might be good to control for people who have been in the business for a while and people who haven't. Because maybe you just get jaded as you get older and it's like, no, I'm not gonna, you know, take the extra steps, versus a newbie. Yeah, all of your research, age usually factors into things, oftentimes geography. So comparing groups, controlling for rival explanations. So like when we get into the crosstabs and we're looking at relationships among variables, if you add in like a third variable and your results change, then that means that that is an important variable and you should somehow include it when you're interpreting the data. If you throw it in and it doesn't really change anything, then it's not a factor. Remember, we talked about confounding factors. You gotta make sure that you've ruled out some of these other potentially important confounding factors. And then the measures of association will tell you how strong is the relationship. Like I mentioned first, these aren't really p-values, real, you know, statistical tests in that manner, but it's more measures of association and strength and weakness of the relationships. And so crosstabs for ordinal and nominal data. It's really important in all of these analysis is you've got to, like I mentioned, I can't stress enough, identify what kind of variable you're dealing with, nominal, ordinal, scale, or ratio. I just had Marie in here before the class started and she's, please stress to the students these different kinds of variables. Because that's one of the biggest mistakes made is the wrong analysis because you didn't identify the type of data correctly. The other one is your independent versus dependent variable. So I always think about it is, I don't know, this is trying to explain the other variable. So, you know, test scores are dependent on age, or, you know, life expectancy is dependent on the number of trips to the doctor for physicals. Think about which variable is influencing the other variable. That variable that's getting influenced is dependent on whatever you're trying to say is making things change. And so when you're doing your crosstabs, your independent variables in the columns and your dependent variable is typically in the rows. So there are some fixed rules for that. Okay. So like I said, you gotta make sure that, your percentages in the independent variable add to 100%. So in this case, we're looking at whether gender influences the favor or opposition of a certain rule, and so it's totally 100% here. So you know that 100% of the male responses is counted for, 100% of the female responses is counted for. If you don't have really small percentages, I mean, in general, you don't need decimal points. Just remove the decimal points, it makes things easier to read. Okay? And lots of times it is helpful to show the total number of respondents in each category. Because I look at this and I'm like, wow, you know, there is a difference. Well, it makes it, it's important whether my sample size is 1,000 or my sample size is 10. You know, I will see things published in the paper and they don't give sample sizes. I'm like, well, how many people did you really include in your survey? So again, getting back to, you might not be doing all these tests, but it's important to know about them and be able to look at it and say, they're good or no, they're full of it. And sample size is always one of those things, if they don't provide it, you're like, I don't know about this. All right. And again, just stressing that when we're looking at crosstabs and these metrics of association, it's just, correlation. It's not causation. And so you can't say this thing causes that thing. They're just related. And whenever you do any statistical analysis, you always have to ask yourself, does it really make sense? There's got to be a brain behind what you're throwing into models or your analyses. Okay, so let's do an example. Say you had the hypothesis of, are you more likely to be religious if you are a woman than if you are a man? Someone wants to test this. Are you more likely to be religious if you're a man than if you're a woman? So, and David, in the chat, will you tell me what are the independent and dependent variables? And how about you two write it down on a piece of paper in class? I gotta get my Zoom back here somehow. All right, I see one answer. All right, what did you guys put down? What's the independent?
I put gender as the independent.
You put gender as the independent, what about you?
For religion is dependent.
You put religion, okay, all right, what do we have here? Independent is gender. Independent is gender, okay. Yes, the independent is gender. If we go back and look at the statement, we're asking if basically gender is influencing your likelihood to be religious. So if a person is a man or woman, are they more likely to be religious? So the status of your religion is dependent on your gender.
Gotcha.
So I have this is probably too small for you to see, but restate the hypothesis as an if-then statement. So if I'm a woman, then I'm more likely to be religious. Okay? So that might help you to think about that. Okay. All right, so crosstabs in SPSS. I think before we get too far in this, I want to have you download the new data set. Because we're going to get into using a whole bunch of recoded variables that I went through and did for you guys. So go to this week's Blackboard. And there should be a SPSS file in there. plastics. Remember your 12 already? Yes. Updated SPSS file, use me. So download that one and you can close down your SPSS and open up that one instead. I'm gonna close down my SPSS. I don't really want to save anything. Open mine back up. And then I think it's called, the same thing, but underscore JS. So you're not gonna see it here because I've already opened it, but you can go to open and then navigate to where your file is. Open data, however you want to get there, there's multiple ways to get there. Okay, everyone have that? Yeah, okay, all right. So then we want to go to descriptive statistics, analyze descriptive statistics, and you will see crosstabs. All right. Oh, I hope I have the CH chat in here. Yep, so CH chat. This will go in the row. Row is usually reserved for the dependent and variable. And then here, we're gonna put sex as the independent variable. Okay? And then go to cells. And here's where you can kind of, mess with what's gonna be put out. Why don't we change this to, percentages columns? Because remember, we wanted our independent variable to add to 100. So we want to get these column percentages. All right. And it's already going to round the cells for you, so you don't have to deal with that issue. And then we'll hit continue. And then okay. All right. So this is the table that you should get. Let me know if you didn't get this. That's what everyone got. Yep, you're good. You're good. Okay. I'm assuming everyone's good. All right. So we got this table here. These are these are called like the margin totals. So when we look at like the total of the columns and the total of the rows, you might see marginal totals. This is what those are called, marginal totals. And so looking at this, does it look like there's a difference between church attendance and males and females?
I would say there does, seems to be a pretty big difference.
Pretty big difference. Who goes to church more?
The woman.
The woman? Yeah, looking at it, never, I mean, 34% of men said never, only 27% of women said that. About weekly, yeah, a lot more women go than men. Typically, the rule is like if there's a 10 percentage point difference, then there's probably a relationship worth exploring. And if we kind of collapse these down, say even further to like seldom to never and about weekly, about monthly, I think the differences would be even more exaggerated. So to me, I mean, it's not quite 10% difference, but there's a difference there worth doing some statistical looking at, and, looking at the measure of association. So we're gonna do that. But this is how you would, this is how you do crosstabs in SPSS. So, yes, there looks like there is, some differences going on there. Okay? So it's pretty easy to do crosstabs. It's more difficult in Excel to do crosstabs. So that's one thing SPSS has going for it. So margin totals, like I mentioned, that's what those are. And no, this did add to 100, so you're good. All right. As I said, you know, it's the 10% rule. Is there an association? What is the strength of the association? That's the statistical approach we're gonna be talking about coming up on how to do that. Right now, we can just say it looks like there is. Okay. And remember, you know, controlling for a third variable or, you know, confounding factors. So if I went back to this example and I threw in education, and education caused the differences between men and women to change, then education would be a confounding factor. And you would want to include that in your analysis as a potential also explanation for, let's say, religion and church attendance. So if you throw something in and this type of distribution changes, then it's important to include.
I have a quick question in this example specifically, but then like in general, does it, when you're putting them in and it asks for like rows and columns, or can you flop those?
Well, I mean, so no, what you can do is you can pull it up again and you can go to analyze descriptive statistics cross tabs. There's no easy button to switch. I wish it did have. Let's see, you can drag,
you can
drag, and then rerun it. I mean, the hard and fast rule about, you know, the ones being the columns, the one being the rows. I mean, that's good to follow, but sometimes the data looks better, flip-flopped and easier to read.
Right,
So-
it's just like more, that's just like the common sense approach is that your columns. Sorry, can you say it in words? Which is your dependent and which is your independent?
Your columns are supposed to be your independent and the rows are supposed to be your dependent.
Okay.
Cause like with the way it is
It's
right
like
now.
X and Y, yeah.
Yeah, X and Y. So your columns would be your independent, which would be your X,
Right,
and dependent is your Y, which is your row.
cool, thank you.
Yeah. Cause like in the example here right now with them flip flop, the males don't total to 100% here. So it's kind of weird to look at. The totals go this way. So you're like, okay, among the people who reported weekly, the split was 60 females and 40 men. Among the people who did about monthly, so you're looking at the splits this way. But, yeah,
Right, which is like, you know, it's just a different question. I feel like in this instance, it still makes sense. It's just a different question. But there's a lot of places where it would be like crazy.
it would be crazy, yeah, and you know, as you get more variables, like if we had 4 variables over here too, then you know, you have a 4x4 table and it's like, ugh, it's even hard, it's hard to keep track of stuff like that.
Okay.
Yeah. Okay. All right, so. So getting into measures of association. So measures of association, as I said, are used to determine the strength of the relationship. So how strong is that relationship between attending church and gender? That's when we would do the tests for measures of association. A 1 would be highly, highly associated, so like a perfect relationship. In the example of gender, would there really be a direction to that? So if we go back and we look at this table here, is there a direction? we're looking at this association. Does it make sense to have a positive or negative association here? No, it doesn't.
Yeah, because you're either one gender or you're not,
Yeah.
I mean,
One's not more important than the other. We're not looking at, you know, education versus, years of education versus say age, where the education goes up, the higher, more and more and more and more school, it's got a direction to it. This one is just male or female, so nominal variables, you don't really have a direction when you're looking at measures of association. One isn't going up while the other one's going down, it's just male or female. Okay? So you can get positive or negative for ordinals, or when you're doing like, correlations with scale or ratio variables, number variables, but not when you're doing it with, nominal. And I can't stress this enough because there are different tests that you do. And you've got to choose wisely when you're doing SPSS, because it'll let you do the wrong tests. Okay, so your book has this general table in it of what measures to use depending on your types of data. So for nominal, there's Kramer's V, phi, that are typically used. And it says, the size of the table. Your SPSS actually likes to use something called lambda. So I don't know why lambda didn't show up there. Lambda should show up. So I would put lambda here by the nominal. And for the ordinal, it's tau B, tau C, or gamma. Reading the manual for SPSS, gamma is the one that they quite frequently use. Unless you qualify for these tau B or tau C, but the default here is lambda and then gamma. And then as I mentioned, if you have interval data, ordinal data, this Pearson's R is what you're gonna use for that. So for nominal, lambda, ordinal, usually gamma for your measures of association. All right. And in your crosstabs, if you click the statistics box, you do have your option to do, your lambda, your phi, for ordinal, your gamma, your Kendall's tau B, tau C. So you must know what type of data am I dealing with here. So no p-values are involved in this at all. It's just going to give you something from 0 to 1, with 1 being the strongest relationship. Okay. This is just kind of a breakdown of how this works. The lambda varies, as I said, between 0 and 1 and indicates the strength. Lambda should only be used when the marginal totals are relatively equal in magnitude. And so what that means, the marginal totals, when I look at this, they should be equal. In this case, they're not. There's a lot of males and not very many females. So in this case, it probably would make sense to use Kramer's V when we go to do our statistics, not lambda, when we're dealing with nominal data. So what's my independent, what's my dependent? What type of data am I dealing with? Here I'm dealing with nominal, and then I do my frequency table and I look to see how balanced am I. And then based on how balanced I am, I do lambda or I do Kramer's V. And believe me, every time I go to do a new analysis on a set data set, I have to look all of this stuff up. I don't remember it. I have to go back to notes and see what's the appropriate thing to do. So I will not have a memory quiz on this. You will have open book.
And
All
on
right.
the difference between lambda and Kramer's V, is that just like lambda you would use when there's a strong enough, seems like there's a strong enough correlation that there is a correlation, but if it's like too strong, then it doesn't work. Or if it's too strong, it's just meaningless. Question.
Well, I mean, lambda is used. If you see that there is looks like there is an association happening, then you would run the frequency table to kind of see if these are balanced. You know, if they look balanced, then run lambda. If your sampling is highly skewed, like for some reason you got more males to respond than females, then you would do the Creamer's V. So it's not really based on whether I think there's a high association or whether I'm thinking there's a moderate association. That doesn't influence which of these stats you do. Rather, it's your sampling frame that influences which statistic you do.
Meaning that there's just a lot more respondents in one category than the other in this
Yeah.
case? Oh,
case,
okay. Got it.
And I just made this data up to show you kind of how you can get skewed data. Okay, so when you do the cross tabs, there is a statistics button and there is this lambda that you can check. And as I said, 0 to 1, 0 is no association, 1 is a perfect association. Again, stressing, this is a strength, but not a statistical test. Okay. And then for ordinal variables, if we have ordinal variables, there's the ordinal options over here. So gamma again varies from 0 to 1. The exact same thing, it's just a stats for ordinal. Okay. And remember how I mentioned that, you know, the coding of text, low, medium, high, and how SPSS also assigns numbers 1, 2, 3. Like I said, it's very nice when you're dealing with this ordinal. 1, 2, 3 will automatically be sorted in the right direction. Low, medium, and high, if you put those alphabetically, they would not be put in the right order at all. You have to be ordered specifically in the direction that you need. Because if you did it alphabetically, it'd be high, low, medium, and that won't make any sense. Okay. And so the measures of association, how do we interpret them? If you get a value of 0.1 to about 1, it's weak. 1 to about 3 is moderate. And then 3 and above is, you know, pretty strong. So when I ask you in your homework assignment, what is the measure of association that you used? What is the value? And what is the strength? I'm gonna be looking for, hey, I did lambda, I got a value of 0.15, and that means there was a moderate strength in the association. Gamma can be negative or positive because it's ordinal. So you could say people tended to agree in one direction or people tended to disagree. It's got a direction to it for the ordinal. And we'll go through some examples here with SPSS. All right, so again, this is your cheat sheet for the gamma and how to interpret it. Positive means they change in the same direction. Negative means they change in the opposite direction. Okay, so let's go back to our crosstab example. So we had this hypothesis that, you know, gender influences religion. We found that women tend to attend church more. Now the next step is there an association? So how do we test for an association? Someone walk me through what we do in SPSS. How about a little?
You said how to do an association.
Yep, so we want to test for whether there is an association between gender and our G-chat, or our C-chat, our attending services. So in this case, are we gonna wanna look at lambda or we wanna look at gamma?
Is it lambda?
Yep, it would be lambda. I
Mhm.
mean, given the sample size, I mean, that's not too skewed. So I think we're okay with lambda. So yeah, we wanna do lambda. So when we're in SPSS, where should I go up here on the top? It's part of crosstabs.
Analyze descriptive statistics across tabs.
Yeah. Analyze descriptive crosstabs.
Oh, am I like making a new table?
You have to go through and make the new table, yes, but now we have to go to the statistics box.
Mm-hmm.
We didn't have anything checked before.
Oh, okay.
Yep. And so now we can check lambda. We want to run some statistics with our table. Yes, SPSS is weird in that you have to read through and go through everything. Yeah. But yeah, so crosstabs, statistics, check your lambda. And then hit
And
continue.
we're already assuming a correlation, so we're not checking correlation.
Well, this is going to check, whether there is an association, which is kind of different than correlation.
Okay,
Correlation, David, that gets into next week's lecture and the statistical tests. Right now, we're just dealing with associations.
okay.
We'll get there. Okay, and so we run that. And what is our lambda in this case? Looking at this, our lambda is 0.345. Is that significant or sorry, is that weak, moderate, or strong?
Is that weak?
Go back to our cheat sheets here.
Oh, oh, it's
I would say strong. Yeah, you only have to have a 0.3 or above for it to be strong. Kind of weird in that, yeah, these two categories are very narrow and this like 0.3 and above, okay, strong. Yeah, but we would have a strong association between gender and attending religious services. So cheat sheets are helpful. Go back to SPSS here. So right here, and we can ignore this approximate statistics for now, but this is the value that you would report, say in your homework or in your capstone project, if you were looking for an association. One thing I noticed is that my tables are still flipped wrong from the exercise that David asked for, so I'm just gonna rerun mine with them flipped right.
So if it doesn't really bear on what we're doing, that's totally fine. But some of the other numbers in this table, like the approximate significance,
Mhm.
is there like a simple kind of lay explanation for like what that's telling us?
Honestly, I don't know. I haven't really paid attention to the approximate significance. Because if I wanna look at this significance, I usually run the correlation statistic that you pointed out before.
So what we're looking for, we're looking at is this approximate capital T, which I'm guessing is lambda.
Yeah,
Okay.
yeah. Okay. So why don't we try another example here? Okay. So Lem just says, yes, there's a difference between men and women. Okay. So what if we have the hypothesis that people in higher social classes tend to have more education? So people in higher social classes tend to have more education. So what would be the dependent variable?
Education.
I'm thinking. I don't think so.
It-
People in higher social classes tend to have more education. So in my mind, classes are influencing education levels.
Right.
So,
And which is how Claudia said it.
is that how you said it?
Yeah.
I said education was the dependent.
Oh,
Well,
maybe not then. Wait,
no, to me-
education dependent. Yeah.
I see what you mean. I think it's just unclear.
okay, people in higher social classes.
If you have better education, then you're in a higher social class.
Yeah, that's how I'm thinking.
Yeah.
Well, yeah, they're different questions, right?
Do people in higher social classes? We want, oops. Girls. Okay. I might have worded it poorly.
Yeah, I mean, so it's
So-
just thinking of it as social classes is gonna run us into problems for one.
Yeah, yeah.
Unless,
So I want rows in to be your classes. And then education to be your independent. Because what I'm trying to say is does your social class influence
No, the other way.
the other way, yeah. People in higher social classes tend to have more education. So if you have more education, you're gonna have a higher social class. I need more coffee. More education equals higher social classes. All right. So, what is the row would be your class. And your independent would be your column, which is education. So. Row is equal to class. And column is equal to education. All right. And so. What type of variables are these? So. Social class, what kind of variable is that?
Ordinal?
Yep, it's ordinal. And
I
then, go ahead.
I mean, that really depends on what we're talking about when we're talking about social class. If we're talking about like wealth, then it's ordinal.
It's talking about like lower, middle, upper class.
Okay.
So I'll just kind of jump ahead here. So lower, working class, middle class, upper class, and then your educational is gonna be less than high school, some college, and graduate studies. Okay, so you're right. Ordinal, and so which statistic do you use, or the measure of association do you use?
Yeah.
Yep, you use gamma, all right. So, let's do our crosstabs.
So did you use EdCat instead of eDuck?
Yep, I used education category because this was one of those collapsed variables and it should be in the database that I have for you guys. Are you not finding it?
No, I found it. I used the other one earlier and it looked like it didn't match with what you had previously on the screen. Because I used the eDuck instead of EdCat.
Okay. So I'm gonna find class here. Yeah, some of these are just, they work better when you kind of collapse the variables. Okay. Statistics. Gamma. Okay. And then hit okay. All right. So we were looking at the relationship between education and social class. And looking at it, does it look like there's a relationship?
Yes.
Yep. Our value down here is 0.97. Or sorry, 0.397, so it's in that high. Yep. And looking at it, we look at less than high school. Working class is where you find people who have less than a high school education. That's what social class they tend to fall out in. And if we go on the other extreme, if we look at graduate studies. That's interesting, the middle class. That's interesting. So people who are in the upper class, they don't really need to have education, they just need to have connections, is what that tells me. Oh, depressing. I'd say there's got some confounding factors in this analysis. That's so sad, only 7.2% of people. Alright. Does that make sense to people?
Yeah.
David, online, you've gone awfully quiet. Did I upset you with this analysis?
No, no. I mean, there are some upsetting things in this analysis, but no. I was running other analyses on the side. Sorry, that's why I got quiet. But I wasn't.
Okay.
I mean, just with different things. There's
Yeah.
a super high correlation between having a turtle as a pet and gender. I kind of thought that was the case, but you know.
Which gender has the turtle?
Men have turtles and birds. It's like
Really?
you get a lambda of like 3.
Okay.
But
All
if
right.
you try to run it with sexual orientation, even if like you don't, first it looks like there's a result, but then it's because of the discrepancy in like responders. If you run the Landers V or whatever,
Mm-hmm.
you don't. It's a very, very weak correlation. But at first it looks like straight people have turtles.
Okay. Wow, they ask about very weird things in this survey.
Yeah.
I know a person who has a bird, I don't know anyone who has a turtle. All right, so the other method of association is correlation. And the correlation is used when you have, numbers. So your integral or your ratio variable, or, called scale variables too. So your Pearson's R is your correlation coefficient, measure of association. And again, it goes, 0 to 1, and it does have a direction, with negative kind of being the opposite. So when one changes one way, the other one changes another way. And the positive is there's a positive association. They change in the same direction. So Pearson's R. Okay. And again, there's a table, you know, for the strengths of the association. So when you look at your values, come back to the table, and then this is how you would say they are strong, moderate, you know, low. Okay. What the Pearsons are, you know, this correlation coefficient, it's gonna tell you the measure of association. But if you square it, you get the coefficient of determination. So this will tell you how much variability is explained by what you're looking at. So say you got a correlation coefficient of 0.04. That would mean that like 4% of what you're seeing in your dependent variable is explained by your independent, say like gender.
Can you say that again? If you have a Pearson's R of what number? Like just in terms of like the raw value? Like
0.04, so you multiply it by 100.
Okay, so it's just a raw percentage.
Yep,
And it's the amount of like the difference in the difference that you're seeing in the dependent variable 5% of that difference can be explained by the independent.
yep.
It's representing. Cool. Okay.
So in that case, 5% isn't very much, you know, there's some, you know, relationship there, but there's a lot of variance in your data that isn't being explained by whatever variable you're using as your independent. Okay, so when you're looking at correlations, a good place to start out is a scatter plot. I think we've all heard of scatter plots before. So let's do a scatter plot in SPSS. So I want to see if there's a correlation between income and age. So go down up to graphs and then down to scatter. Click on the simple scatter and put in your independent and dependent variables there. In this case, we think age influences how much money you make.
And it's the same thing here, we put the dependent on the x-axis, or the other way.
The dependent goes on the y-axis. So when you have a chart y, x, this is usually your independent. And this is your dependent.
Which income are we
A
gonna
reclassified income, this RECINC.
Okay. Was that reclassifying? This might be me just being too nerdy about this, but I'm really enjoying this. Like this program's amazing. That income thing is family income. So I
Let's
guess
check.
Yeah.
It's
Okay.
reclassifying a variable called income.
Right.
I reclassified it so it, before it was categorical, and you basically take the center, so HI income. Let me see, trying to think, I think it was income 16, so it was ours, family. No, it was total family income,
Okay. Okay.
yeah. Total family income. And so it had these categories of under 1,000, 1,000 to 3,000. And so what I did is I made this 500, I made this 100, 1,500, 2,500. So I kind of, you know, broke it into numbers so that we could do a regression.
Okay.
Okay. All right. And so you should get a result that looks like this. I'll do it quickly in my SPSS. Graphs, scatter, simple, define,
Uh,
y is income.
yeah, it looks weird to me. Oh,
It
no,
does.
that's because it's classified. Yeah, okay.
Yeah,
It's like supposed to look weird.
Lil, is this what you got too?
Yes.
Yeah. Alright, so there you go, you have a scatter plot, we're looking at it and it looks like maybe there's an association, you know, there's definitely a lot more variability once you start getting out of college, it looks like, to around the age of 25 here. And then as you get, into retirement, the variability starts to drop down again, so that's one thing I noticed. All right, so it looks like maybe there's something there. So now we want to do our measure of association. Okay, we want to do our test. So let's close this. And we're gonna do the Pearsons. So go to analyze. Go down to correlate. And then go over to bivariate. Got it? Okay. All right. So when we're in here, put in age and the other variable. All right, and then it was rec income, reclassified income. Okay. All right, and we have the Pearsons checked down here. All right. One thing I would do before we move on with this is go to options. Okay. You have this exclude cases pairwise and you have exclude cases listwise. So imagine that we had an example here where we had more variables than just income or than age. Say we had education in here and we had age trying to explain income. And lots of times when you're dealing with data sets, there's missing values. So maybe someone gives you their education but doesn't want to give their age. And so you have information for one of the variables, one of your predictors, but not the other. If you check this exclude case pairwise, it'll still include it. Even though you don't have both variables predicting your dependent, it'll include it. If you check this one, it'll throw it out. You only take whole cases where you have 100% data. Usually it's good to just leave this checked as the exclude cases pairwise. So we use more of our data. Okay? So make sure that's all done, then hit continue and then hit OK. And so we see that we have a Pearson's correlation of 0.218. So is that weak? Is that moderate, strong?
It's moderate.
This sounds
It's-
moderate.
Yep, moderate. Yep. And what percent of the variation is explained by this? Where?
Yeah, whatever 0.218 spirit is.
0.04, 4%.
4%, okay.
So, age explains some of income, but it really isn't all the story there. Yeah. Okay. All right. One thing that I did want to show you with this education is, let me find it here. Okay. Here we see education. You know, it's scaled as nominal, but we actually, you know, used it kind of as a numeric value, you know, because it did vary, it does go up. So if we look at education and we look at it in the data view, over to education. It's actually a number. I mean, this, if we do a frequency on education, it's a number. I wouldn't consider this a nominal variable. I would treat it like a number. So don't always believe what SPSS says for the type of variable. Think about your variables and make a decision based on what the data is showing you. Because if I, look at this and I do like a frequency for this category. So exploratory data is so important. I look at this. It's a number. It goes from no education all the way up to 20. So that's why I would treat it as I do with this correlation as a numeric value, not ordinal. Does that make sense to people? Look at your data. Logic means my way. Okay. All right, so I mentioned, kind of hinted that age is not a very good predictor of income. What if we threw a third variable in there? Let's throw in there education. So let's go back to our analyze, correlate, and go down to bivariate and throw education in there. So EDUC. All right, and then run the same statistics. All right, so looking at the results. Is education related to income?
Yes.
Yes. Is it stronger or weaker than age?
Stronger, much stronger.
Much stronger, yeah. So you can see the value is 0.36 versus the age was 0.218. So age is moderate, income is strong. So in this case, it's definitely a confounding factor, and you would want to include education and age in any prediction of people's income. Okay?
Good.
All right, so while we're dealing with this, let's go back to that scatter plot. So I want you to make a scatter plot of education. So education on the X, and I want the income on the Y. So scatter plot. And so your Y should be education, EDUC. And your income should be the Y and your education should be the X. Sorry if I reversed that.
And you want us to use that rec ink or income?
Yes. So I want it to look like that. Your Y-axis is the rec income, and then your X-axis is the education. And hit OK. And so you get a graph like this. And now we're gonna learn how to add the regression line to it. So go up to your graph and click on it. And go to edit. All right, you get this chart editor that pops up. And move it over. And you'll see this, this little box here that you can click. over here that shows like a little line going through the scatter plots. Right here. When you click on that little box, you'll have this come up. And so you
Is
wanna
it-
have a link.
What's the word that comes up when you hover it? Is it add fit line at total?
Yes, add fit line, add total.
Okay.
For some reason, it didn't come up when I was hovering here. I don't know. There we go. Now it came up. Add fit line, add total. And it might have a second one to learn. Oh, no, I don't want something curvy. See if I can delete this. Okay, there it's gone. All right, so go up to here and I want the linear. You can take a look at some of the other options here, lines. Change my line color, it looks like. I haven't really played with any of these. But the most important thing is linear. And apply. So now you have,
What about the confidence intervals part? Just not worried about that for now.
I'm not worried about that for now. I mean, if you wanted to, you can play around with it and put some confidence intervals on it. But that's kind of past the statistical stuff that we're gonna do today. Very wide confidence intervals. So a lot of noise in your data. So what that's saying is, like with a 95% confidence, the prediction of income based on your education is gonna fall between these two lines.
Okay.
Yeah.
Oh, so they're sort of kind of like error bars.
They're sort of kind of like error bars, yeah.
Okay.
Yep. But that's how you would add a regression line to a scatter plot that you put together. And this is actually pretty easy to do in Excel too. And then you have an equation up here, your R squared. Okay. So any questions about that? No? Okay. Well, let's take a break. Let's take like a break till, a 10-minute break till 7:20. And then we'll come back and talk a little bit more about linear regression. Okay?
Cool.
And I'm sure David online will do all sorts of crazy analyses and tell us when we come back.
So I actually have a question since we're taking a break.
Mhm.
For week 11? No,
Mhm.
11. Oh, yes, week 11, assignment 11, getting to know GSS. So was that supposed to be like in class or like just,
On your own.
oh, okay. Oh, okay.
Yeah, we didn't have time to do it. Last week we went over a lot of, computer stuff again,
Yeah.
which is fine. So I just turned it into a homework assignment.
Okay, thanks. I must have missed that.
Okay, don't worry, just, turn it in when you get a chance to do it.
Sweet, thank you.
Yep. Okay, so those of you who are back, I would like you guys to just have some fun and pick your own measure of association to do. So David has already looked at turtles and gender. Pick something besides turtles and gender. In Blackboard, if you go to that GSS folder, there's the code book there. And that explains what the different variables mean. So this one was like, women only were asked, women should be able to have legal abortions. So I want you to pick two variables and do some type of measure of association. I don't care if you pick nominal, ordinal, but pick two that are interesting to you and then figure out what's the proper measure of association to do. So I think the way I might do it is like, look at my variable view here and this label. And see which ones look interesting, and if I don't understand it enough, I might look at that code book.
Jane, can you go back to screen share, please?
Oh, I'm sorry, yes.
That's okay. Yeah, this is
So-
challenge. Thought I was getting this, but like now I'm trying to figure out if people who have cats are more likely to have dogs. And I can't I need the code book or something. It's
Okay.
hard.
Well, okay, I suggested going to the variable view, and this is where you could get the information, but if like you're struggling with what does that parameter mean? Yeah, you can go to the folder, the GSS folder on Blackboard. And there's this appendix A code book, and you could try to find your cat and dog in here and look at it a little bit more closely.
Oh yeah. Well, the part I'm stuck at is like interpreting the the results of the
Okay.
class.
Okay. Well, I'll let the other three people come up with their interesting ones, and then we can go around and take a look at people's results and try to interpret them.
Cool. And everyone else in the class, if you haven't noticed yet, it might be helpful, really helpful to know that if you look at that results window, it's continuous. So like your old results are still there, so you don't have to rerun old things if you want to look at them again.
Yeah, you can, save them and have them all there, yep. Confidence in Congress, ha ha ha. Last use of crack cocaine. Oh, some wild stuff in there. And just let me know when you're done. Claudia, are you done?
Yes, I am.
Okay, are you done?
Yep.
Yep, okay. All right, people in the room are done. David, you're done. Alil, are you done?
I am almost done.
Okay, just let me know. Then we'll start.
For running crosstabs. Oh, you can't run 3 things in a crosstab? No, that's what makes it a cross.
That would be like a mind-boggling 3D matrix.
Oh, but in general, if you think something is the independent variable, you want to put in columns. And that way it arranges horizontally, so it's like your x-axis, the thing that you think is independent.
Independent in columns, yes.
Okay.
Raise your hand. Believe me, when I was a graduate student, these terms confused me too. Because there's so many different names for them. All right, so Alil is done. All right, so why don't we start first with David in class? What did you do?
I wanted to see if there's a correlation between people who owns cats and if they were tired of living.
Living, okay.
Wait, David, can you say like if they were tired of living?
Yeah, so if you have a cat, then you're
That's
tired.
exactly what I was just running. Okay, but yeah, you're right. It's so weird. That's so
Okay, we got people who think alike here. You guys should be roommates. Okay, so what did you put in your rows for your crosstab?
That would be suicide 4.
Okay, let's see, cat, oh god, okay, suicide. Okay, all right, so it's cats influence suicide. All right, so what's the dependent and what's the independent?
Dependent is suicide.
Yep,
And cats are independent.
yep, exactly right, okay. So dependent rows, you put
Rose, suicide.
suicide, yep, yeah,
Suicide 4.
oh boy. Oh. Well, good thing we're getting this out of the way.
yeah.
All right, and I thought there was 2 cats here.
Yeah, I think one was if you had a cat and one was if you currently have a cat.
Okay. If you've lost your cat, then it goes up.
Yeah.
All right, which cat?
Just regular cat.
Regular cat, okay. All right, so let's just take a look at what this looks like without looking at the statistics part. All right, so. So walk me through what you're seeing here, David, in the class.
there is nobody who has a cat is tired of, no. There is 76% of people that have a cat are not tired of living,
right?
and 23.5% of people with a cat are tired of living.
All right, so tell me a story. That's when you get into your dissertation or your capstone reports, you gotta take these numbers and tell a story. So what story is this table telling?
That if you have a cat, you're more likely to not be tired of living. Yeah,
Yes, or to not have so many negatives in it. If you don't have a cat, you might be more tired of living, or if you have a cat, you're less tired, you know, you wanna live,
right, okay.
if that makes sense. I mean, this is almost a 10% difference here. Right? If you have a cat, if you don't have a cat, 84% said that no, they don't, they're not thinking of suicide, but you know, if they have a cat, it drops down to 76%. So,
Okay, yes, I see.
so to me, that says having a cat means you're less likely to say, I'm tired of living.
Right.
Your cat is keeping you going.
Yeah, but not by much.
Well, I mean, let's check. So, okay, what would be the appropriate statistical test then to do for this?
Um. Um. Maybe gamma?
Yeah, okay.
Or would it be more plan?
Well, what's the question you have to answer in order to decide which which measure of association you're gonna do? There's two questions. One was in which is the independent and which is the dependent. The second question you need to answer is,
Is it nominal or ordinal?
So, do I have a cat? Is that nominal or ordinal?
That'd be ordinal? Nominal?
Are you saying that it's much better to have a cat than not have a cat?
Well, I mean, the data seems to say that a little bit.
It's nominal. It's just a yes or no answer. No biases in here.
Okay,
All right, and have you, thought of suicide? Is that nominal or ordinal?
that's nominal.
Nominal. So we're dealing with two nominal variables here.
Right.
So which one do we use?
Lambda.
I would say lambda. I didn't look to see if the data was highly skewed, but let's say lambda. We hit okay. And I can see why David online is confused. Okay. All right. And so you get something like this. This to me says that it's highly significant. You're kind of just getting these values that are all zero, which means that it's so strongly significant that it's kind of off the charts. One thing is, you know, if we did treat them as ordinal, we see we get a value of 0.249 here. Which, you know, indicates that there is a negative correlation, which we kind of, or association, which we saw. If you say, yes, I have a cat, you're gonna say, you know, you haven't suicide if tired of living. So if you say yes to this, you usually say no to suicide. Yes, I have a cat, no to the suicide question. That's an opposite relationship.
Right.
So in my interpretation of this, yes, there is an association and it is a strong association.
in those, in that directional measures chart though, when it says cat dependent, this is something that was really confusing me on my printouts. It seems like it's not like something's going on, like it's not actually cross tabbing, it's like it's parallel tabbing or whatever the opposite of cross would be. It's like
Mhm.
it's like asking how likely you are to have a cat based on whether or not you have a cat.
Yeah, it's looking like it's, when you have like a correlation matrix, you get ones whenever you're looking at variables that are being compared to themselves.
Mhm.
That appears kind of what it's doing. Yes, it is very funny. I'm looking at this and these are like highly skewed. You have an answer of 40 here and you have an answer of 173 here for your total. Not very many people reported that, suicide. So I'm gonna try this with the other measure since it is so skewed. So I'm gonna just go back and take a look at it. Analyze descriptive crosstab statistics. And I'm gonna pick this one, turn this one off, just to see what it does. Okay. So in this situation, it's telling us that Kramer's V is incorporating the fact that it's a rather relatively unbalanced relationship here. This is saying that it's actually a weak relationship when you account for the sample size between owning a cat and suicide. Based on this statistical type of measure.
Okay,
So in hindsight, I think this is the more appropriate thing to use is the Kramer's V because of the highly skewed nature. And it gives us a result. Whereas the other one was giving us kind of weird nonsense stuff. And that might also be due to this really disproportionate sample size.
okay,
Does that make sense, David, online?
Yeah, that makes sense. So I was actually comparing cat to a different thing, which was if you think life is exciting, boring, or dull.
Mhm.
So exact, I guess, was a hyperbole, but like related, definitely. Um,
Mhm.
and it's not correlating.
Yeah, okay. Well, that kind of, yeah, once we correct for the lopsided sample size, the same thing here. I think I would probably not hang my hat on this result because of the highly skewed nature of the data.
okay,
But,
okay.
yeah, if that's the solution, I would go to a medical professional before the cat solution.
Sure,
Yeah,
okay.
okay. All right, Alil, what did you do?
So I just did, how do I phrase this? Well, I chose popular and sex. And so I think the statement is, oh boy. Or how being popular is what, like, most important, or how is popularity important? Oh boy. Sorry, I like did not think of the phrasing. Um,
What's the variable here? How do you spell it? P-O-P, popular right here? To be well liked to popular?
yeah, it's just popular. Yep.
Okay, all right, I know how you would say it. Let's have you try again. So you did the sex and you did popular.
Yes.
So how would we phrase that? Think of our first example where we had gender and we had religion.
Well, that one was like how your gender determines how religious you are, right?
Yep,
And so this would be your gender determines how important it is to be well liked or popular.
that's what I would say. Let's take a look at the code book and see kind of what the question is for that. I'm gonna pull up the PDF. That'll take me forever to scroll through that thing. Party, okay. Pick up sex, popular. Okay, I'm just looking at this. Okay, to be well liked or popular. So one is that's the most important thing in my life. Second, most important, third most important, fourth most important. So we are saying that gender influences how important it is to a person to be well liked or popular.
Oh, that was so much better.
Code book is helpful. Okay, so the independent is gonna be gender and popularity, opinion towards popularity is your dependent.
Mhm.
Okay, all right. So we'll go back to SPSS here and we'll do our cross tabs. All right. Good. Goodbye suicide, hello popularity. All right, so in our columns, we want to have gender.
Mhm.
Is that what you did?
Yes.
Okay. Or it was called sex, sorry. Sex, okay. And in the rows, popular. Okay, all right, before we go there, what kind of data are these? So what kind of data is sex? What type? Will?
Nominal,
Yep, nominal. What about popular?
ordinal.
Yep, yes, I would say ordinal. It could be ordinal, yep. All right. So, let's just first look at what the crosstab shows us. All right, so these are totaling to 100, so that's good. All right, so you've looked at this. What is it saying?
Well, I thought it was interesting, from 1 through 5, most important to least important. There are more men in each category. To find it important. Well, with the least important, I thought that was a little interesting, 491 compared to the 681, just because my assumption would have been the opposite, that women would care about being well liked or popular.
Mm-hmm. Mm-hmm.
But yeah, maybe that's probably due to yeah, I'm not really sure. But something about like stature, like, in the workplace or like with friends and like fitting in and whatnot.
Yep, so, we can't say that gender causes people to be more interested in being well-liked or more popular. But we can say that there looks like there is an association in that actually men seem to have it higher up on their importance list to be popular than what women do. But among both sexes, among all surveyed, it doesn't fall very high. I mean, less than 1% of people really cared about being popular regardless of sex. Okay? So that's kind of how I would describe it if I had to put it into a paragraph in a paper. Looking at the sample size, 705, 837, that's not too skewed. For that big of a sample size, that's not bad. So based on that, what type of, measure of association would you do?
I chose. I went with lambda.
Yeah, okay. I would probably choose lambda too, just because our variable that is independent in trying to, tell how popularity is influenced is nominal, and there's not really a direction. It wouldn't really make sense to have a negative or positive assigned with this because it's a man or a woman. So yes, I would choose lambda. So analyze descriptive crosstabs, statistics. I would do the lambda, yep. And then we take a look at it. And the value looks like it's 0.82, 0.082. So what's the interpretation of that?
0.8, 0.08. Is that low?
Yeah, low.
Okay. Right, because that range was like 0.321, right? For lambda?
Yeah.
Oh.
Mhm. Yep, so overall pretty low. Okay. Claudia, what did you do?
I did grooming rating versus,
Grooming?
yeah, like how well groomed the respondent is.
Ooh.
It's are groomed.
Are groomed, okay.
Versus whether or not they have a cat. Please be that.
Are groomed, grooming rating, okay, I gotta check this out here. See it in here, are groomed? Yeah. RG. Okay, I don't see it in here, I don't know why. I wanna look at the values, so, okay. One is very poorly groomed, oh my goodness, there's a lot of categories. Okay, all right, so right off the bat, what type of data is this?
This is ordinal.
Yep, ordinal, okay, so groom versus what?
Siblings, number of siblings.
Number of siblings, okay.
Sibs.
Sibs, okay. So what's a kind of a hypothesis for that?
Well, I thought that the more siblings you have, the less likely you are to be well groomed.
Okay. So you're, okay, yeah, there's not, you gotta fight for the bathroom here, all right. So your dependent would be,
The dependent would be groomed.
yep. Yep, and your independent would be the number of siblings, yep, okay, all right. This is interesting, okay, and what was your next step? Did you do crosstabs? Did you do a scatter plot?
So I did the scatter plot first.
Okay, because
And
I see that this is scale over here, yep, and let's see, your other one was Sibs, what's the name for it?
sibs.
Sibs, okay. Let me go down and look at Sibs. You have brothers and sisters?
I have one sister.
One sister, okay, Sibs, yep, okay. Yes, all right, cool, so scatter plot, all right. And then what was your X and what was your Y?
So my X was sibs. And my Y was overgroomed.
Okay. See what this looks like, I'm curious. Huh. Okay. All right. 1 was very poorly.
Yes,
Okay, 5 is really groomed. Oh, interesting. So what is this graph telling us?
it tells me that there's like nothing there. I think maybe like as you get to the extremes, the people with a lot of siblings tend to be well groomed. But it seems like most people are in the middle.
Who the heck has 25 brothers and sisters? Wow. What if we put a line on this thing? Ah, that line is pretty flat. Okay. Okay. All right, so I mean, the thing that's is deceiving about this is we don't know how big these dots are. You know, how many, you know, this dot represents. I don't know about an SPSS, but like in R, you can vary the dot size by the count. And then you can get a good idea, but looking at this line, I'm saying there's probably not much of a relationship
So
here.
I thought that too, so that's why I did the cross paths.
Okay. But what, in this case, what would be the measure of association you wanna do?
I did gamma.
Okay. That would be wrong. Because I mean, well. Let's see. Both of these actually kind of are scale, so Pearson's R is typically the
Okay.
one that you use when you're looking at things that are a scale like this.
I guess my
Yeah.
logic was that the number of siblings is scale, but how groomed you are is ordinal.
But in this example here, this one was ordinal in, a Will's example of gender is how popular you are. The statistic is telling you whether gender is associated with popularity. So we didn't do the one for ordinal because it wouldn't really make sense to have a direction to it.
Okay.
Because men don't, you know, men and women don't have a direction to it. So in this one, what you're looking for is as my number of siblings increases, does the groomed kind of also increase?
Okay.
I mean, you can get into an argument, you know, which one is correct, and I'm sure you could statistically justify each of them, because, you know, this is an ordinal variable, but I would probably go with the Pearson's. So you recall how to do that?
Yes,
Okay,
so for Pearson, I would go to analyze
Mhm.
and then correlate
mm-hmm,
and then bivariate.
yep,
And then I would take out those old ones and put in my 2 new ones, which are groomed and sibs.
okay, see what it says. Oh boy, 0.004. So, very, very low, yep, which is interesting, yeah, your number of siblings does not influence, your grooming ability. Yeah. Does that make sense?
Yeah.
Huh. I would have thought that there probably would be a relationship. I would wonder if you cut this data at like 10 or below, what it might look like, because these seem to be pretty far out there.
That's what I thought too, and then like I noticed that the outliers, like the people over 10, they're like all over the place, so I wonder if that's
Yeah.
messing up the data.
Huh. Yeah, more exploration to do. But this is an example of, you know, I see this and I just submitted a paper and the reviews came back, predicting why houses burn. And it's, you know, a regression that we did. And the people reviewing the paper want to see histograms of all of our explanatory variables where we can. Because they want to see what is the distribution of, say, the number of brothers or sisters, see what it looks like. And then they can kind of make inferences as to whether, you know, outliers are causing this, you know, correlations to happen or not happen. So, yeah, something like this, I go back and, all right, let me do a whole bunch of basic statistics, look at distributions, the data itself. Yeah. Okay. Cool. All right, any questions about that? Yeah. All right, and so to get into a question that had popped up earlier, about X's and Y's, simple linear regression. And this is from basic stats, you have this error term, so it's trying to find the best fit line. It's trying to put a line through these, say, dots, where these total the smallest amount. So your error is how far off is your real data from the predicted data. And I'm sure you guys have seen the equation, y equals a plus b1 times x. So this here is your dependent variable, and your b here is your independent variable. So when you get like coefficients from your regression modeling, you can plug in the a and b values that you get, and then you can predict something based on your x value. So, when we did the regression, you just did the number of siblings and grooming. Technically, you could put in any value of number of siblings and get the predicted level of grooming for a person. Okay, so we're always trying to minimize this error. And as I said, you could have a positive correlation, a negative correlation, or in our last example, no correlation whatsoever. So both X and Y are positively increasing. In this example, your X is increasing, but your Y goes down as your X changes. Okay? All right. And so I just kind of put together a little cheat sheet for how I would go about, linear regression. Look at your variables, as frequencies. I don't know why I have, if you have not, it's not a complete sentence there, so sorry, let me look at your variables as frequencies, and or scatter plots, I think is what I meant. Okay, so look at your variables, visually inspect them, determine the level of measurement. So what type of variable are they? Identify your dependent and independent variables. Do the correlation. So your Pearson's R. And then I would square that Pearson's R to see how much variability is explained. And then I have another, do the scatter plot, and then I'd probably put a line on it, like we did. And then run a regression to get the equation. So those are kind of my steps for doing, the regression analysis. So let's run through a regression analysis in the program here. So let's do, again, this education and reclassified income. So to do a linear regression, you go up to analyze, regression, and go down to linear. Also pull it up here. Analyze, regression, linear. Okay. And so we're wanting to see if income is explained by education. So let's go down to our reclassified income. And then our education. Okay. Let's go to statistics. And we have the estimates checked, and we have our model fit checked, so that's good. That's all good, so make sure those are checked. Go to options. And this exclude cases list is checked, so that's good. Make sure that this use probability of F. What this is doing is that, if a variable, is significant at the 5% level, keep it in the model. When you have, regression, sometimes you can have lots of predictors. You're throwing everything in there to see if it's related to whatever dependent variable you're putting in there. And so what this will do is it'll step through each of your predictors and say, is it significant? If so, keep it in the model. It'll add the next one, rerun the regression. Are those two now significant? If they're both significant, keep them in the model. If it hits one and it's like not significant, it removes it from the model. And the thing about this process is it kind of looks for multicollinearity. Has anyone heard of multicollinearity?
No.
Basically, it's as you add variables to a model, they're interacting with each other. And so as they interact with each other, something might not become important anymore. In our example, we had age in here at one point in time. Maybe we have age and age is important, but then we start to add education and it swamps age and age no longer is important. And so it gets thrown out of our model because it dropped below this 5% threshold. So it goes through and tries to check how they're interacting and whether to keep them in or drop them. So it's a nice way to, pare down your important variables. So, okay, then you hit continue and then hit okay. All right, and then we have our output here. So based on this, education is significant. We have a p-value of less than 0.001. So that says definitely there is a relationship there. We're looking at the relationship and this is the coefficient down here. And so it's positive. So what does that mean? We have a positive coefficient.
It's a positive relationship, so as one increases, so does the other.
Yep. So as your education goes up, your income goes up, is what that is saying. And statistically significant that variable is. This one up here tells you the overall model is good. This one here tells you this individual parameter is important. Okay. So what if we go back and let's throw age in this regression. So let's go back to analyze, regression, linear, and throw age in there as one of the predictors. Okay. Have age in there and then hit okay. So this is multiple linear regression. When you have two predictors in there, it turns into multiple linear regression. And we click OK. All right. And so I look at this. And overall, the model is still significant. And now see, I have a p-value for each of my independent variables. And both of them are significant. Both of them have a p-value of less than 0.001 at the 5% level. So both of these are significant predictors of income. So if I go back here and just remove that, I'll just go back and remove it. Remove this age. Okay, so to keep it simple, I've done this analysis, and so I've walked through it here. And remember that equation of y equals a, which is the intercept, plus your coefficient times x. So this is how it relates here. So income is equal to, this is your intercept, this constant is your intercept. So minus 25,000 plus your coefficient here, which is 4,533 times education. So according to our model, if you had someone with 12 years of school, their predicted income is $39,000. That's how you put it back together.
Wow.
So if you had the line, that's what it would predict. Yeah. And in the paper I said earlier, they're asking us to make a map of all of our predicted values. So, using these equations and getting your predicted values is important. Figuring out how to take your coefficients and turn it back into an equation. But, you know, again, it's also a perspective of reading results that are published, you know, being able to look at this and say, oh, this coefficient is positive, that means there's, you know, a relationship that's going in a positive manner, both increase, and it is. Okay. And again, a warning that SPSS will allow you to do crazy and stupid things, so you really gotta answer, what is my variable? So we're almost near the end here. I would like you guys each to do a linear regression of your own choice.
Okay.
No cats this time, no cats.
In setting up the linear regression,
Yeah,
is it very important? Do you have to set it up differently if you're using ordinal or nominal or a mixture?
linear regression is only to be done with things that are a scale.
Okay.
So, you know, even
You have to-
though like, Claudia's example with the groomed,
Uh-huh.
SPSS says it was, what did SPS say this R groomed was? R groomed. How do you, where is it? R,
I think it did say it was scale.
did it say it was scale?
But I thought in my head it was.
Okay, that, I guess, it's thinking about the variables and saying, okay, is this something that could be like a 1, 2, 3, 4, 5, a number? It's okay to treat it as a scale, but a linear regression should really only be done with stuff that is a scale, so that means it either a ratio, or an integral.
Okay.
there like a way to remove the outliers? Like automatically, or would you have to go like?
That's a good question. I would have to do Googling to see. I'm sure there's a way to remove outliers. Yeah, I know how I would do it in R, in Excel. I'm not sure how you would do it here. If you would put like some type of filter in first. I know, there are tests that you could do to see if your data has outliers. And then when you do those tests, they'll flag what the outliers are. And then based on that, you can remove the outliers. You gotta have a very good reason to remove outliers.
Well, I feel like here, the outliers are like so egregious that for me, it's like
Okay,
obvious.
and the way you would test that is like looking at the interquartile range or how many standard deviations are they outside of the mean? That's what some of those tests do.
Okay,
Yeah. So what did you do for your regression?
okay. I'm gonna laugh. So I did height versus number of sex partners since 18.
Okay, so does your height determine the number of sex partners you have? Okay,
And then it didn't combine them, so I just did number of female sex partners.
okay, all right, so. No. Height, so. Trying to get there. Okay, height, would be your independent, and your dependent is sex partners. Does that start with X?
It's-
S?
Numb woman.
No, okay. All right. Numb woman, okay. All right, I'm just gonna look at my statistics, okay. All right, let's see what it says. Oh, goodness, it's significant. So, all right, it's significant, and is the relation positive or negative?
It's positive.
Positive, so the taller you are, the more female sexual partners you have in life. Is that what that's saying?
Yes, but if you look at the scatter plot, I think you'll see what I mean with
Okay,
the outliers.
scatter plot, all right. Some really tall people here or something, you have me intrigued here.
Well,
Or
one big confounding thing that I don't know what we're gonna see on the scatter plot here, but like there's definitely a lot more straight people responding to this survey, and women on the average tend to be shorter. So that's gonna be hugely responsible for that significance. Because
And
like
how
you're gonna get it, because well, oh no, because it So this is a question I actually have a lot with a lot of these responses is like, is it accounting for,
He says that.
what is like Kareem Abdul-Jabbar in this database or something like that?
I have a
Sorry,
question about this.
Go ahead, David.
Is this including for example, in this specific example, is this including the responses of heterosexual women in like the number of female sex partners? Or are
Yeah.
those like a type of non-respondents or something, or like not applicables? In general, like is your sense of how this database works?
That's where I would go to the code book and take a look and see if, the number of sex partners, number of women, number of female sex partners since 18. I don't see where this asks specifically the number of males and the number of, among males, the number of female sex partners. To me, this would be, it would include males and females.
Okay. So if we were curious about that, like could we also in the regression thing, could we also include like gender and sexual orientation and like it would fold those into the
That would be kind of a slightly different regression because those are not scale variables. Those
Okay.
are, nominal. And so you would be getting more into something like called an ANOVA.
okay,
Which we'll talk about maybe in a couple of class periods. But I don't think it would be appropriate to just throw them into this analysis. But,
Okay.
what you could do is do some, the basic statistics, look at the graphs and look at the crosstabs and see if they're changing, when you throw it in there.
okay,
Yeah, or like a histogram too, of the two, to see if, yeah. Looking at maybe some scatter plots and seeing if there's different relationships that kind of come to light. Yeah. That's what I would do, and then a different type of analysis, but okay. All right, we're over time. Do people have burning desires to go over their ones, or do you want to call it their analysis? David, you're grinning.
I'm okay.
You're okay?
Yeah.
All right, how about you guys online? Are you burning to have yours put up?
no.
You're like, no.
I mean, I'd be happy to talk about this if anyone wants to, but I'm not burning to push it on anyone, no.
Okay. All right, well, we went over a lot today. We actually did get through everything. And, like I said, it can be very, very frustrating, kind of very, very confusing to do this. Because as you see, there's a fine line, it can be nominal, it can be scale. So just try your best. And like I said, when it comes to doing analysis, I, go back to my statistics books. I look at papers that have done similar analysis, use similar type of data, see what they do. Because in all of your research papers, every method that you mention, you need to have a citation for it. And I made that comment on the couple of drafts that I read. If you mention a method, have a citation that proves that that is the appropriate method for statistical analysis to use. Okay? So yeah. All right, awesome. Thank you, guys. And I'll see you in a week.
Awesome. Thank you.